He was walking toward a light pole when he heard his own car move behind him. 3 feet of standing water in a Denver suburb. The middle of August. He turns around, and his car is floating. His name is Kevin Plowman, and I'll come back to him, because what he did was the reasonable thing. That's the problem. 2 hours later, the county gave up on the water and sent out the snowplows. Not a typo. Snowplows. In August. And the reason they worked is the part almost nobody covered. At that intersection, Meridian Boulevard and Maroon Circle, just outside Denver, first responders waded into about 3 feet of standing water. Underneath it, by their own estimate on scene, was another 2 to 3 feet of accumulated hail. Kevin's own words, "As I made my way to the light pole, I felt the car pick up off the ground, and that's when I knew I was starting to float." He got out through the window. 7 people were pulled from their vehicles in about 90 minutes. Every outlet in the country ran the same image. Snowplows. In August. It's a great picture. And almost nobody asked the question underneath it. Why was there enough hail on a suburban road in Colorado to need a plow at all? That's this channel in one line. The loudest version of a story and the true version are almost never the same one. Because the answer here isn't a Colorado story. It starts about 700 miles away, and it explains something that roughly 97 million Americans were living through that same weekend without ever connecting it to this. Here's how fast it went. Around 2:30 in the afternoon, storms fire along the Front Range. Within minutes, South Metro Fire Rescue is responding to stranded drivers at flooded intersections around Meridian and Lincoln, east of I-25. Aurora Fire Rescue takes more than 15 separate 911 calls. By 3 o'clock, the FAA has a ground delay program running at Denver International, averaging 104 minutes. 25 minutes after that, it escalates to a full ground stop. By 4, South Metro has pulled 7 people out of their vehicles. The flash flood warning for southern Douglas County runs until 4:45. 2 hours and 15 minutes, start to finish. And inside that window, a second driver, Allison Mora, is stuck in Aurora watching her engine die. Quote, "I was crossing this, and I got stuck in the middle of the water, and I couldn't move. My car died, and a guy came with a truck and saved me." Now here's where the story stops behaving the way you'd expect. When you hear hail deep enough to plow, you go looking for the monsters. And they were there. The largest hail report in Colorado that day was 1.75 inches, golf ball, just southwest of Foxfield in Arapahoe County, a few miles from where the plows ended up, and minutes before the water started rising. But that number is a trap, and it's the trap almost all of the coverage walked into. A storm report records the biggest stone somebody happened to find and call in. It tells you nothing at all, about how much ice came down. And the thing that plugs a storm drain and stacks 3 feet deep is never the biggest stone. It's the bulk. And the bulk is small, nickel-sized, which is exactly what the warnings that afternoon were advertising. The kind of hail you'd stand in. The kind nobody bothers filming. So this was never a story about how big the hailstones were. It's a story about how many there were, and about what a very large quantity of very small ice does to a city. A city street doesn't handle rain by absorbing it. It's a sealed surface. Every drop that lands has exactly one job: get to a storm drain. Small hail is the perfect thing to defeat that system. It's light enough to be carried by moving water, and small enough to pack. It flows downhill with the runoff, arrives at the drain grate, and wedges. Not one stone blocking one opening. Thousands of them locking together into a plug of ice. And once the drains are sealed, the rain that's still falling has nowhere to go at all. Several rain gauges in Aurora picked up 2 or more inches in a single hour that afternoon. In a semi-arid climate, That 1 hour is roughly 12% of everything the place normally gets in an entire year. On a functioning drainage system, that's a bad afternoon. On a drainage system packed shut with ice, that's 3 feet of standing water in an intersection. The hail didn't arrive with the flood. The hail built the flood. That's the mechanism, and it's the part I'd stake the video on. If that was new to you, subscribe. This channel is 90% that kind of thing, because it also opens a question the Colorado story can't answer on its own. A semi-arid state in an extreme drought does not produce tropical rainfall rates. Something had to bring that much water here. Hold on to that. And this is the part that makes it genuinely dangerous rather than just strange. 12 inches of water is enough to float most cars. 18 to 24 inches will carry away most vehicles on the road, including trucks and SUVs. Those aren't dramatic numbers. Those are the National Weather Service's standing figures. Now put 2 to 3 feet of ice slush underneath. From the driver's seat, the surface tells you nothing. You can't see the bottom. You can't judge the depth. And the floor you're assuming is under there, solid pavement you could roll through slowly, isn't pavement. It's a moving mass of ice. Which brings us back to the man walking toward the light pole. Kevin wasn't being reckless. He was doing the thing that looks safe. The water read shallow, so he left the car and went for higher ground on foot. It read shallow because there was a mass of ice under it, not pavement. The floor he was judging by wasn't a floor. It's also why the county sent plows instead of pumps. You can pump water. You cannot pump 3 feet of hail. And keep that clock in mind. 2 hours and 15 minutes. First storm to expired warning. That speed isn't a Colorado detail. It's a fingerprint. And it points about 700 miles away. There's a second factor, and it runs exactly opposite to intuition. The Front Range went into this storm in extreme to exceptional drought after a very dry winter, which sounds like it should help. Dry ground has room to take on water. It doesn't work that way. Soil that's been baked hard for months turns hydrophobic. The surface seals. Instead of soaking in, the first heavy rain sheets straight off it, the same way water beads on a dry sponge before it ever softens. So the ground was shedding water and the drains were packed with ice at the same time, in the same place. And here's the uncomfortable part. That rain was genuinely needed. The same storm that put 7 people in the water was drought relief for a region that badly needed it. Relief and disaster, out of one cloud, in one afternoon. So where did the moisture come from? Look at the whole continent that weekend and there's exactly one feature running the board. A massive heat dome parked over the central and southern plains. That dome is what pushed temperatures to 100 degrees across a dozen states, with heat index values as high as 115 in the southeast. Roughly 97 million people, from the Central Plains through the southeast, were under heat advisories. And this was on top of a July that had already gone into the books as the hottest month ever recorded in the contiguous United States. But a heat dome isn't just a hot spot, it's a high-pressure system, and in the northern hemisphere those circulate clockwise, which means that while the center of it is baking Kansas and Oklahoma, its western edge is doing something completely different. It's pulling deep subtropical moisture northward, up out of Mexico and the desert southwest, and steering it onto the Colorado Front Range. That's the North American monsoon, and the dome is what aims it. Forecasters had been flagging a subtropical moisture surge into the Front Range for the end of that week. It arrived over storms slow enough to unload everything they had in one place. Deep tropical moisture, slow-moving storms, sealed ground, ice in the drains. Every one of those is downstream of the same feature, which gives you the actual shape of that week. One system, 3 completely different disasters, depending entirely on which side of it you were standing. On the south side, dangerous heat, and 97 million people under advisories. That's the story everyone covered. On the north side, where the dome's edge meets the jet stream, the severe thunderstorm corridor across the upper Midwest. That's the story the weather channels were watching. And on the west side, the flank almost nobody was looking at, a fire hose of tropical moisture aimed at the Colorado Front Range. That's the one that floated a man's car and shut down departures at one of the busiest airports in the country. The heat wasn't the story that got people. The heat's side effect was, before I show you the last piece, let me be straight about what's solid here and what isn't. I think that matters more than sounding certain. What happened in Douglas County, the rescues, the depths, the timeline, that's reported and sourced. The hail depth specifically is a responder's on-scene estimate, not a survey, and I'd treat it that way. The mechanism? Small hail-packing storm drains and turning ordinary rain into flash flooding is well established. That's the part I'd stake the video on. And the piece I'm about to show you is the least certain of the three. It's a probability, not a promise. I'm putting it last on purpose, and I'll tell you exactly where the confidence runs out. NOAA is on an El Niño advisory. Their words, from the August 13th diagnostic discussion, El Niño is strengthening, with a greater than 90% chance of a very strong event during the Northern Hemisphere fall and winter. 23 of 26 models agree on it. And that's already doing something visible. The Atlantic has managed 3 tropical storms and 0 hurricanes. Total accumulated cyclone energy for the season sits at 3.1 units. Effectively nothing. Colorado State cut its final outlook on August 5th to 9 named storms. 4 hurricanes, 1 major, down from 13, 6, and 2 back in April. Now, you'll see a version of this online, arguing that the quiet Atlantic is storing up energy for 1 catastrophic late-season hurricane. I want to be careful here, because that framing is doing more work than the evidence supports. The suppression is mechanical. Wind shear plus Saharan dust and sinking dry air. Wind shear over the Caribbean this July was the highest since records began in 1979. And that shear is forecast to strengthen, not relax. A quiet season can absolutely still produce 1 serious storm. It only takes 1, and that's true. But energy is accumulating, for a monster is a story, not a forecast. The better supported signal is what a very strong El Niño does to a North American winter. It tends to reorganize the storm track. Wetter across the southern tier, milder across the north. That's the next chapter of this exact pattern. It's months away, and unlike a heat dome, it's something you can actually plan around. If that changes, I'll say so in a follow-up rather than quietly leaving it up. So go back to that plow for a second. It wasn't clearing snow, and it wasn't really clearing hail either. It was clearing the thing that had sealed the drains shut. The reason an ordinary summer thunderstorm put 3 feet of water in an intersection in 90 minutes, in a state that was in a drought, 700 miles from the system that caused it. The loud story that weekend was a heat index near 115 degrees and 97 million people under advisories. This was the same system, same week, just the side nobody was watching. And the practical version, if you take one thing, a flooded road during a hailstorm is worse than it looks, and it's worse specifically because it looks shallow. There may be feet of ice under a surface that's telling you nothing. Turn around. That rule was written for exactly this. Out of everything here, the hail plugging the drains, the drought making it worse, that eerily quiet Atlantic, which one did you not know about? Tell me in the comments. It usually tells me what the next episode should be. This has been The Hidden Signal. I'll see you in the next one.